Hello, and welcome to The Science Show, the show where we learn about science. I'm Paul Benoit, and today we're going to look at the ways that people acquire knowledge and answer the question, what is science? Whether it's your aunt on Facebook who's always posting about how the government's putting mind control drugs in the water, or your favorite celebrity telling everyone how effective the newest miracle diet is, you're constantly being bombarded with claims about information in your daily life. Being able to tell what information is true, or at least knowing what questions you should ask, is more important than ever to being informed and making good choices. So how do we get good information? Well, we use science. Or more specifically, we use the scientific method to examine and test what we think about the world. But before we look at the scientific method, we need to look at how people acquire knowledge. Generally speaking, there are 5 non-scientific ways of acquiring knowledge. We use these methods in our everyday lives, but oftentimes these methods are flawed. The first method is the method of tenacity, holding on to beliefs because of habit or superstition. Basically, you believe what you believe, trusting information that conforms to that belief and rejecting information that goes against it. Most folk sayings can be seen this way. For example, think about the expression, "You can't teach an old dog new tricks." Really, you can teach an old dog new tricks. I mean, just go on Instagram for like 5 minutes. The statement, "you can't teach an old dog new tricks," doesn't stand up to real-world evidence, but people believe it anyway. It's a bit of a silly example, but it illustrates the fundamental problem with this method. If your information isn't accurate, there's no way to correct it because you aren't looking for the truth. You just believe what you want. The next method is the method of intuition, accepting information that feels right. Now, people make choices based on gut feelings all the time. Do I want fries or salad with my burger? Ultimately, the decision comes down to your intuition, and that's fine. Intuition is fast, and it works well when there's no information about the situation. But if you base your knowledge on a feeling rather than on facts, there's no way to separate knowledge that's accurate from what's inaccurate. For example, if you go to a casino and put all your money on lucky number 7 because you have a good feeling about it, well, that's probably a bad idea. The facts are, betting all your money at the casino is very unlikely to produce the results you want. The third method is the method of authority, accepting information because an expert tells it to you. Now, you might be saying, isn't that like how the entire education system works? Well, yeah, it is. Trusting teachers and textbooks to give you accurate information. The method's a good way to build a foundation of knowledge, especially when you're starting out. But the big flaw in it is that it assumes that the person you're asking will give you accurate information. Another big pitfall is that it assumes that experts with very specialized information have more general knowledge than they actually do. When Nobel Prize-winning chemist Linus Pauling claimed that vitamin C cures the common cold, most people believed him. I mean, he is a chemist after all. It makes sense he would know. Or does it? Well, actually, despite what many people still believe today, there is no proof that vitamin C has any ability to cure the common cold. Just because Linus Pauling was an expert and had specific expert knowledge doesn't mean he knew everything about chemistry. Another big pitfall is that experts can be biased or subjective. A movie critic is an expert, right? Then why would one critic give a movie a good review and another critic give it a bad one? It's because those are opinions, not facts, and we have to be careful not to mix up the two. The fourth method is the rational method, seeking knowledge by logical reasoning. Logical reasoning in this method means a very specific thing, taking known facts or assumptions, called premise statements, and using logic to figure out new information. For example, all 3-year-old kids are afraid of the dark. That's the first premise. Sarah is a 3-year-old kid. That's the second premise. So, if Sarah is 3 and all 3-year-olds are afraid of the dark, then Sarah must be afraid of the dark too. Makes sense, right? Well, no. Some of you might have already thought, hey, not all 3-year-olds are afraid of the dark. And you'd be right. One of our starting premises was wrong, so whatever logically we figured out was wrong too. A big problem with using the rational method to acquire knowledge is that you need to be sure that the premises you're using are actually true to start with. Another big problem with the rational method is that humans are terrible at analyzing logical arguments. So what if we ignore the rational method and try to figure things out only with evidence? The fifth method is the empirical method, using observations or direct experience to acquire knowledge. You use the empirical method every day for all kinds of things. You can find out someone's weight by having them step on a scale. You can figure out the temperature by looking at a thermometer. You know that snow is cold and boiling water is hot because you've observed these things to be true. It's perfect, right? Seeing is believing after all. Well, not exactly. See, the empirical method still has plenty of problems. The first problem is that you can't trust everything you see, hear, or feel. Optical illusions show that your brain can be tricked pretty easily. The second problem is that people's perception of events is influenced by all sorts of factors, like prior knowledge or emotions. Remember when you were a kid and you thought your teachers lived at school? Then you learn people go home and after they go to work. You still observed the teachers only at school, but your knowledge influenced what conclusions you drew. The third problem is that you can make accurate observations but misinterpret what they mean. People used to think that the sun orbited around the Earth, and why wouldn't they? It's not true, but if you just trusted what you saw and no other facts, you wouldn't know. So if all these methods are flawed, then what do? We still have to learn about stuff somehow. Well, that's where the scientific method comes in. It combines features from a few of these methods, taking their strengths and reducing their weaknesses. The scientific method uses observations to develop a hypothesis or explanation, then uses the hypothesis to make logical predictions, and finally tests those predictions with systematic empirical observations. This method combines the method of intuition, method of authority, rational method, and empirical method to acquire new information. So how exactly is this done? First, you start with an observation about the world. This doesn't have to be well thought out, just something you notice in your own life, or something someone says to you. Maybe you notice that you feel more depressed in the winter than in the summer. You could just assume that you're right, and it's probably true for everyone, but the scientific method allows you to take your observation and test it. Second, you form a tentative explanation or answer, a hypothesis. For our example, the hypothesis is that winter makes people more depressed. Now, you have to identify characteristics or conditions that change or are different from person to person. These are called variables. These can be based on common sense or what you think to be true. A hypothesis is a statement that describes or explains a relationship between variables. For our example, we could look at the weather. Maybe people are more depressed in the winter because the weather is darker than in the summer. The weather is a variable, and so is someone's level of depression. The third step is to make a testable prediction. Since we think that worse weather in the winter leads people to be more depressed, then we could say, take a bunch of students and swap out their dorm room light bulbs, the bulbs that are half as bright. We would predict, based on our hypothesis, that students who get less light, all other things being equal, will become more depressed than their peers in full light. Taking our general hypothesis and narrowing it down uses the rational method we talked about earlier. If our hypothesis is universally true, then this specific application will be true too. Fourth, we make a systematic observation to test our prediction. For a hypothesis to be useful for science, it has to be testable. In our example, we can switch the light bulbs and record which student has which brightness. Then we can measure depression levels of students with questionnaires designed to detect depression. By the end of our experiment, we'll have a clear result that we can use to tell if we were right or wrong. Without being able to gather data, you can't do science. Finally, we examine the data against our predictions. Maybe we find that the students with the darker rooms showed more signs of depression than the others, but not every student. Or maybe we find that the students in the bright rooms show more depression. Now, whatever the result, we can refine our predictions and try another experiment. Science isn't something to be done once, but a cycle of making predictions, testing them, and refining them with new information we learn. This new information lets us make better predictions, and the cycle repeats. Each time, our knowledge becomes greater. There are a few other factors that make science work. First, science is empirical. No matter how obvious the hypothesis, you can't know anything without making observations and gathering data. But unlike the method of empiricism that relies on your own subjective experience, science is systematic. That is, it uses careful, planned observations that we can measure or control. Science is also public. We make our observations available for the world to see. When you do a scientific study, you publish it, and you also publish all the steps you took to find your results, so that other scientists can try the same experiment out for themselves. If they do the same thing as you but get a different result, then maybe there's something wrong with the experiment. Or maybe they think, you know, that was an interesting study about the weather, but I bet if we looked at temperature too, it would change the results. Then they can run their own experiment and share it with you, and overall everyone learns more. Science has to be verified by other people. Finally, science is objective. We design experiments that collect data that's separate from our personal feelings or viewpoints. No matter what I believe, who has which light bulb in their dorm room isn't going to change. Wow, that was a lot of information to take in. We learned how people acquire knowledge and the limitations of each method. We also looked at the scientific method, the method that defines science. Next week, we'll look at the different ways to do science based on what we're trying to learn. Until then, see you next week.